Welcome to part 2 in the series of videos where we're building an Airbnb-like system, but unlike Airbnb, the system will be meant for rent. Now, if this is your first time here, welcome, and you have not seen the previous video, I go in detail or I discuss about the architecture in that previous video. Link is in the description. Now, here's what will be covered in today's video. We'll be preparing the database, we'll be creating the auth and configuration modules, and finally, we'll create the user servers. Assuming you have Postgres running, connect to it and create a database. I'm calling mine Away, which is the name of the project. Create these extensions to simplify geolocation queries. The UUID extension, as you may have guessed by now, we use that for generating UUIDs. On the project repository, we have an ER diagram of the database. If you're interested in that, you can have a look at it. But otherwise, you can run the setup.sql file, and this will create the database tables, the triggers, and the necessary indexes. At the moment, we only have a single trigger, which is responsible for creating a user's default subscription whenever they register. Now, just so that we have some data to initially work with, run what is in the fillup.sql file. A quick word about the property combinations table. It allows us to have certain categories applicable only to certain types of properties and not for others. What I mean here is, according to the combinations table, if someone selects the property type of ID2, which is a house, then only category IDs 3, 4, and 5 should be available. Likewise, if someone selects a property type of flat, then only flat and apartment should be applicable for category selection. We would want each service to be able to verify requests. Now, instead of writing this code in every service, we can create a separate auth module which will take care of this and then be shared among all the services. If any of the imports fail, simply do a go-get together with the module name. We'll have a function to set up the Firebase auth client. A reference is made to the server's account key file, which doesn't exist yet, but we'll take care of that later on. Create the interceptor file. In here, we'll simply have an interceptor function. All it will do is get a token from the metadata and then verify this token with Firebase. We have functions to extract the user ID and email from the provided token. Now, in addition to the email address, there are also other fields which you can extract depending on your use case. We then add the email and user ID as a payload to the context and return that. Let's take care of that service account key file. Create a Firebase project and head over to the project settings, then service accounts. Get the service account private key and place it in the config folder. Rename it to service account key. The auth module is ready. The penultimate module of today is the configuration. In the config directory, create a YAML config file and declare some constants. Initialize the Go module and create a config.go file. This function is mostly simple, as all it will do is load up the configuration file. Fantastic, we now get to start on the user servers. First up, we initialize the Go module, and then write the protocol buffer definition file. As of now, these are the only RPC methods in the user servers. Should it be necessary, more can be added later on. A side note about the getUserResponse. We would want it to only return the user message if the requesting party is requesting their own information. Otherwise, we respond with a minimal user info message. The reasoning here is we wouldn't want just anyone out there to view someone else's subscription status or device token and so on. The other messages will be kept simple for now. To generate the code, we need the protobuf compiler installed. Download it and add it to the environment variables. In addition, make sure the Go bin directory is also in the environment variables. Install the Go plugins and run the commands to generate the code. Create the user servers under the server folder. Now, because I'm sure I'll be using the other two modules from earlier on, I can modify the Go mod file to use a local version instead of looking it up on GitHub. In the struct, inherit the unimplemented user server. One of the things it does is handle the RPC calls, which we haven't implemented. We set up the database connection in the initialization function with the config values. Heading over to the create user implementation, we first retrieve the payload from the context and then get the user ID and email. The user can then be added to the database. However, it's possible that the user ID already exists, and due to constraints, the database won't allow duplicates. We could return a generic error to the client like could not create user, but let's add some code to check if the user already exists in the error we get back. So cast the error into a Postgres error and then match the error code accordingly. Next up is the getUser function. Just as before, the relevant data is retrieved from the context. As per requirements, the user message is returned if the request is from the owner. We can directly set the created field of the user when doing the query, so a temporary variable is used. The same is done for minimal user info, but fewer fields are fetched. The update and delete functions will simply do the relevant SQL and give the response. Create the entry point file. All it will do is load the configuration, set up the authentication interceptor, and then finally start up the user servers. Compile and run the program. To make sure the authentication bit works, we'll need a Firebase user together with their token. On the dashboard, create a testing user. Go to the project settings and take note of the web API key. Open up Postman and request Google for the user's token. This token is valid for an hour. I'll be using Bloom RPC to send requests to the user servers. First method we'll call is a create user. Add the token to the metadata. Let's get the user by their ID. Awesome, it works. To confirm the minimal user message is returned when the conditions are met, I have created an additional user, Jane. It's not quite working as expected. The info returned is of the requesting user and not the ID passed. The query happens to be using the wrong ID. Let's fix that and run it again. Great, works just as expected. And that's why writing tests is important, so we might cover that later on. That's it for today's video, and thanks for watching.